Hello everyone, today I'll be teaching you how to do the power rule. So you need to be familiarized with this formula. So x raised to n dx. So in order to make the power rule is that you need to, when x n plus 1, you need to add 1 to the exponent. Then at the bottom, you need to n plus 1 plus c, of course. So that should be your final answer when, let's say, solving for the power rule. Our first example would be the integral of x dx. As you can see, here in the dx, there is an x. Therefore, we should only integrate the x part, which is here. So integrate using the power rule. Power rule x. Here we have a 1 exponent plus 1. Here, since we have a 1 exponent, there's always a 1 here. Keep that in mind. So since we have a 1 exponent, here we should go 1 plus 1. And then 1 plus 1 is equals to 2. Then all over 2 plus c. And that, everyone, should be your final answer. Next is example number 2. Oh, sorry about that. Example number 2. X, y, dx. As you can see here, we only have dx here. Therefore, we should only integrate the x and consider y as a constant. So here is, you need to, since y is a constant, you need to put it here. So x, 1 plus 1 all over 1 plus 1. And you should be met with y raised to 2, y squared all over 2. And to, let's say, simplify it further, you just need to x squared all over, x squared y all over 2. And don't forget the plus c. Yeah, it's really that simple. So in order to recap, we only integrated the x just because here in the d there is an x. If here was a y, we should only integrate the y. On to the next problem. Into the third problem. The integral of 2x plus 3x squared dx. So what you're going to do is that you need to distribute the integral. And this should be integral of 2x plus the integral of 3x squared dx. Since you distributed the integral, you should also distribute the dx. So don't forget about that, kids. After that is, you just need to do the power rule. And when doing this power rule is, you need to, let's say, put the constants outside the integral sign. Next is that outside is 2. The integral of x dx plus 3, the integral of x squared dx. And that should be 2, 1 plus 1, x squared all over 2 plus 3. 2 plus 1 is equals to 3 all over 3. And this should cancel out, cancel out. And then we would be left with x squared plus x cubed. And don't forget the plus c. You should put it in green because it's a nice color. So if you if you derive this one, you should let's say get this one, this equation, if you derive this. All right, on to the fourth problem. So our fourth problem is the integral of e raised to x dx. Now don't be, let's say, intimidated with this. Don't be intimidated with this, let's say, equation. What we're going to do is that we need to keep in mind the formula, which is 1 all over a e raised to ax plus c. That's what I think the formula when dealing with this thing. So as you can see, e raised to 1, raised to x, there's always a 1 here. There's always a 1 there. Therefore, our constant is this 1 here. Okay? Then, so 1, the constant 1 all over 1, e raised to 1 x. And simplify it further, e raised to x plus c. So let's emphasize the e further. So e raised to x plus c. So that should be our final answer. And on to the last problem that we have, which is, sorry about that, which is the integral of e raised to 2x. Here we have the constant number 2. 2x dx. Here we have the constant number 2 because here is a dx. So the formula, which is 1 over the constant, which is 2, then e 2x plus c. You could write this as your final answer, but you could always simplify this, which is e 2x all over 2 plus c. There. That should do the trick. Either way, any of these two would suffice. So that's all of it. I hope you drink your water, and also good luck in your examination. Goodbye.